All right, next we're going to talk about paired samples t-test. So with paired sample t-test, remember the kind of questions we're asking here are about comparing the means or the averages from the same group of people. Now typically these are going to be, or commonly, like two variables at different time points. This example we have down here is children's ability to express their grief. The pink bar is before they started attending grief support groups at the sharing place, and then this is after. So it's the same kids, right, before and after, and seeing did things change from before they started using those services to when they were finished using those services. Um, the My kids' elementary school use paired samples t-test all the time. They'll take these tests at the beginning of the school year to see how kids are doing on their math scores. Then they'll take that same test in the middle of the year, and they want to know are classes improving, and if they're not, then they're going to use that data to help target certain classes that maybe need some extra help. Right, but the thing is, they're comparing a class to themselves versus if they wanted to say, well, does teacher A versus teacher B, are their students doing better? That would be an independent samples t-test. So again, key thing is here, it's the data are coming from the same people. Now we're going to use very similar code here as we've used before. List the APA function or use the APA function. You're going to specify an object name into t-test, and then you're going to list two variables, and then say paired equals true. Now let's jump back one slide here. A key thing is here, both of these variables are continuous or ordinal. That's a key point. So one continuous or ordinal variable and a second continuous or ordinal variable. It's going to give you output just like we saw with the one sample t-test, in terms of giving you the T, the P, and the Cohen's D. But then we also want to get the means for each variable. So we could run describe, which would work just fine. This function mean here also, it just gives you the mean of that one variable versus everything that describe gives you. But describe would work just fine here too. All right, let's jump back to RStudio. And let's pull up our code book. What kind of questions or question do we want to ask? We've got conflict and intimacy with family members. And maybe I'm curious, well, this could be interesting too. Let's look at the differential treatment. Okay. Or, oh, this is a good one. So there's this idea that as siblings get older, moving past midlife, so really talking like in your late 50s, that sibling relationships kind of reemerge as being these really important relationships, um, and that they become more important than they were perhaps in the past, in midlife. So we could actually kind of test that question here with this data. We've got this question that says 10 to 15 years ago. These are all like 55 plus year olds. We got a lot of 60, 70, 80 year olds in the sample. So 10 to 15 years ago, how important was your sibling? Um, Lower numbers here would be, one would be like the most important person, two among the most three important people, three among the six most important people, those kind of things. And is that changing from what it was to what it is now? We've got these two means, but again, is that changing over time? Or are these two means different from each other? A key thing here is, right, it's the same people reporting on what their relationships were and also reporting on what they are now. So sib import past, sib import cur. Okay, question. Are siblings more important now than they were 10 to 15 years ago? So we're going to do APA. Let's call it paired test. I mean, really, it doesn't matter what we call this object. And I can't spell either. Paired test. Then we're going to do into and t dot test and our data frame, money symbol, sib import past, and our second one, sib import current. And this is key, you need to see paired equals true. So we're saying, hey, this is a paired t-test. And let's run that. I always start with the p-value here. That p-value is 0.327, so we're saying there's a 32.7% chance that there's no difference between these two numbers given the data we have. That's too high, right? And we need it less than 5%, less than 0.05 for us to say it's statistically significant. So another way, and we're going to interpret this and just say there's no difference between these two. They are the same. Now we're going to just get the means of both of these numbers. We have it technically in the code book too, or we could run describe here. Either way is fine. But then we got those two means, and we're saying, yep, these two things are not actually different from one another. Okay, that is paired samples t-test.